But as we start getting into more advanced applications, whether these be SaaS providers or other sort of enterprise level applications that need to do more advanced background work, and especially with the rise of machine learning models, and social media forums and things that require more advanced computing, you kind of need a bigger worker, some bigger resources that don't fit in the typical life cycle of how Celery applications run. A lot of microservices and applications tend to have background work that needs to be done. For instance, if you've got a website that is registering users and you need them to certify what their email is, typically you'll send that request to some background work system that will email the user, and then send the user to the confirmation dialog through the email, and then you've got a registered user. Some work is really pretty quick, like sending an email request off to your email system is not a compute intensive task. And in fact, if that takes a couple seconds, that's pretty long. But, as we start getting into more advanced applications, whether these be SaaS providers or other sort of, enterprise level applications that need to do more advanced background work, and especially with the rise of machine learning models, and social media forums and things that require more advanced computing, you kind of need a bigger worker, some bigger resources that don't fit in the typical life cycle of how Celery applications run.
Yeah.
Right. So the Celery workers, because they use this queue as an intermediary for getting work, these are long-lived processes that are essentially polling a queue like an SQS queue to say, do you have work for me? The number of workers that you have should scale up and down based on the requests that are coming in over time. So that's something that Batch is built for. It was explicitly built for, having a queue and a orchestration of resources tied to each other, so that you can do workload aware scaling of your application's needs. Right. Because Celery workers are paying attention to this queue, right? Batch itself has its own job queue, but distributed background tasks are paying attention to a central queue like SQS. And some Celery workers are quick, like I said, sending an email. And it's more appropriate to have small microservices containers running alongside your application for those small requests. You really only want to send the compute intensive work over to AWS Batch, these really long, expensive processes. So what we have in the architecture is a queue, like you're sending your requests specifically to a queue that is meant for batch requests. And in the blog post, I show how you segregate simple requests like emails to one queue, and then more compute intensive tasks to a separate SQS queue that is meant for batch to look at. So you're sending these compute intensive tasks that are background work. They don't need to be run completely, but you might still have some service level agreement to do it within the next 10 minutes. So you need something to watch that queue to see how big it gets. So we have these CloudWatch alarms that are set to the approximate number of messages in the queue. And this alarm will enter the alarm state when the queue messages are above 5. And, if you get a lot of work in, I have a separate alarm that says, we got a lot of work coming in here. There's more than 50 messages. I'm going to set off like a really high alert alarm, right? And for each of these alarms, we're using, a serverless architecture patterns, and particularly event bridge rules to say, launch one worker when you have a modest amount of work. But when you have a lot of work coming in and like a stampede of work coming in, and you still need to meet that service level agreement, launch 10 of those workers, right? So in the blog post, but not in the example, I talk about how you can layer in another piece of functionality with AWS step functions, right? Where the step function itself is looking at the queue depth. And then that step function state machine will take a look at how many messages are in and start the appropriate number of workers, again, based on our 5 and 50 criteria. And then it'll wait. And then it'll check the queue depth again, and then launch more workers and wait. So this is kind of like a behind the scenes iterative scheduler that will go and meet the requirements of that. Like you don't you're past 50, and you're getting a whole bunch of stuff, and you still need to keep scaling. And the central point here being that if your application has some really wild and unpredictable patterns, then you might need to introduce something like a step function, something that keeps checking the queue to keep scaling. So if we go into the CDK project, so if you see here, we're just creating EC2 constructs. We're using this new CDK level 2 construct for batch. I'm really pretty excited about this. It's in alpha right now, but we're marching towards a GA release for it. But it makes creating batch CDK stacks much easier. So you can see that we create a SQS queue that's specifically named Celery batch, right? And yada, 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 right? This is not too interesting. This is just AWS architecture. If we go back to the project and look at the container that we create with CDK, you'll see this Celery app and a couple of runner scripts, as well as something to fill the queue, which I'll show in a second. This is where we should really be looking at. In short, right here, these 2 lines are showing where you create the Celery application itself. You tell it to use SQS as a broker. And you tell it that the default queue is called this, and you're going to route this specific method to a separate queue than the default. And here's how the Python decorator works for Celery, right? You essentially add that this is going to be a task, and then you say calculate pi. So let me go here so that you can see how this works in practice. Basically, you apply synchronous or delay are the 2 methods for Celery methods that have been decorated. And this thing will now run in the background. Right? So it's as simple as that, as far as your application is concerned. CloudFormation, you see that I launched the CDK stack. It did a whole bunch of resources. You see here in the AWS Batch console, you see that it created a job queue for Celery jobs from the CDK stack SQS. You see that we created the queue itself. You see that there are 0 messages in it right now. And since there are 0 messages, you don't expect either of these CloudWatch alarms to be an alarm. So let's go and actually launch some jobs. We showed how to fill the queue. We showed the application itself. Now, what about the workers? And this is the entry point for our container. It's basically a bash script that will activate a Python environment that has all our Python dependencies, including Celery. And then we start Celery workers based on the queue name that we have passed in as a batch job parameter. And then while this process is running, while there are still messages in the queue, you just do a look, see regularly how many messages are left in the queue, and if there's still more, go back to sleep, right? Because your workers are still working. Once there are no more messages in the queue, send a sig term signal to the process ID of the worker, and then that worker itself will finish the work it's doing and then shut down. And then once that process ID file is no longer there, basically exit successfully from the container. I'm going to launch 5 messages into the queue. Actually, let's do 10 messages into the queue for goodness sake. There they are. Right?
There we are.
Got 10 messages. And if we go back to our scaling alarms, right, we see that we're in alarm. We go over to the batch queue. We see that there's 1 job running. Here's that Celery worker itself, right? So this thing should be going off and showing that we have the Celery worker process, right? That we've outputted and that it's going through and doing the work.
Celery gets used by everybody from data scientists to live website operators. I mean, this is a very popular distributed task management tool, right?
Absolutely. And I've already had, we published it yesterday. I've already had a couple of folks from media, from the media industry, contact me about having more information, and financial services, right? Both of these industries do background work processing. They use Celery or another background test queue. So if you're in JavaScript land, a really popular distributed task system is called BullMQ. You could take the same pattern and swap out Celery and put in a BullMQ container, and you'd be off into the same races. You'd be scaling your BullMQ workers that do the compute-intensive tasks on batch.
If you learned something from this talk, then please consider giving us a like and subscribing to the channel so you can find out when more videos like this are available. And if there's an area you'd like to see us go deeper into, don't hesitate to reach out and let us know. See you next time.